Hello, my name is Kawajash Bemagazi, and I'll be talking about mapping functions and placement algorithms for cache memory. First and foremost, we need to define what cache memory is. And cache memory is basically just a small, high-speed volatile computer memory, and it's most frequently used programs, applications, and data. It reduces the latency and improves system efficiency. This basically means that it's going to reduce time it takes for the CPU to access a word from memory. It does this by storing if a word is accessed earlier from the CPU from main memory, it will store that word and keep it for future reference. So the next time the CPU needs to access that word, doesn't have to go back to the main memory and just cache memory, and that reduces time, hence the efficiency. So this brings us to cache memory mapping functions. And cache memory mapping basically means the process used to determine where data block from a memory is going to be stored in a cache memory line. And one of the methods used is direct mapping, which is one-to-one correspondence between memory blocks and cache line. It means that the first block will most likely is actually going to be stored in the first cache line, as simple as that. The next one is associative mapping, and here this is the most flexible but complex type of memory mapping. And here block the block from the main memory will be assigned any part of cache line. It's not directly going to go to the one or the second. It's just going to be assigned randomly and will be put anywhere. However, address of this block is actually split into parts. There is a part that they call a tag and the part that they call the word. And yeah, next one is the set associative mapping technique, and this is a compromise between direct and the fully associative. Here we break the cache lines into sets, and we break them into sets. These blocks assigned into those sets, but in a sort of manner similar to that of associative mapping, because it is random. It's not directly one-to-one. It is random. It could be stored anywhere, but these cache lines have been broken into different sets, and this helps to prevent contention, which is very likely in case of direct mapping, as a word may be said to be stored in the same cache line as another word, and this will cause a rise of contention. Then this brings us to actually how the memory replaced occurs, what criteria is followed. And the first one is actually least recently used. Now, here, as the name says, the least recently used item or word in a cache line will be discarded. And the next one is the first in, first out. This one removes the oldest cache line. It can be catastrophic because the first cache, the first in cache line would actually be the most required. And this means the next time it is called, you have to go back all the way to main memory to access it, and that increases the latency. Then we have the least frequently used. As the word says, the least frequently used item or the word will be accessed here and discarded, and this is done using a counter, which is basically a clock algorithm in a computer, and this is just such as the number of times specific instruction or word has been accessed by the CPU. And last one is the random replacement. And this is just in a word random, anything can go in, anything can go out. And it is also catastrophic, just like the FIFO, because it increases latency for the same reason. Now, in conclusion, we can see that the cache memory mapping replacement algorithms actually optimize complete performance. The goal is to increase the speed of access for words from memory, but we also want them to be cheap, and the choice depends on specific use. This basically means that the choice of method going to be used for mapping or replacement will depend on the required use. If you want it to be fast, you're going to choose certain methods because some are faster and cheaper. others are cheaper, and you find that there's actually always a trade-off, because those that are normally cheap are not as fast, but those that are fast actually very expensive. So you have to make a decision depending on what you want. Do you want it to be fast and you know to spend money? Do you want to just be cheap? Then you're going to have a slower speed for accessing the words from your memory. And then finally, we obviously not with the evolving technology, we're going to have better strategies for efficiency, and they're going to become obviously faster, and they're going to become cheaper. Thank you.